Hi everyone, welcome to Cogtalk. It's wonderful that you could join us here, and I'm especially pleased that Professor Donald very graciously agreed to give us this talk. The Cogtalk is being organized by the Center for Neural and Cognitive Sciences at the University of Hyderabad. At the moment, I would also like to welcome Professor Ramesh Mishra, Department Chair at the Center for Neural and Cognitive Sciences, as a discussant. My name is Sitama Gupta. I'm an intern at the CNCS and the student moderator for this particular session of Cogtalk. I myself have masters in cognitive psychology, and at the moment I'm interning here and working with Professor Mishra. So let me begin by introducing our speaker. He's an adjunct professor at Case Western Reserve University, Cleveland, Ohio, where he's also the founding chair of the Cognitive Science Department. His early empirical work was in the field of human cognitive and clinical neuroscience with a specialization in electrophysiology. For the latter half of his career, he revisited the topic of human intellectual and cognitive origins. He is trying to understand how the slow-moving biology of the brain can deal with the changing cognitive ecology. The work brings together several disciplines in the sciences, social sciences, and humanities. Professor Donald has written several books, including Origins of the Modern Mind, Three Stages in the Evolution of Culture, Cognition, and more recently, A Mind So Rare. These two books in particular have had a significant impact on various subfields of social sciences and sciences. Joining him today is Professor Ramesh Mishra, the head of Center of Neural and Cognitive Sciences at the University of Hyderabad. His research interests include areas of bilingualism, language processing, attention, and visual processing. Most recently, he has published a book entitled Bilingualism and Cognitive Control, where he discusses the contested cognitive advantages present amongst bilinguals. Currently, he is interested in the areas of attentional control and conscious awareness. Before we start, I would like to let you know some things. Everyone who is here is in the listen only mode, so you will be able to hear and see us. And I'll just tell you a little bit about the structure of how the talk is going to be. First, Professor Donald will give us the talk about his work, following which there'll be a short talk with Professor Mishra regarding the work and referring to key points within the talk. And in the end, we will go through the questions that you are encouraged to think of and write as the talk is progressing. There is a small Q&A option at the bottom of your Zoom screen, which you can click and type your questions. Yeah, and we will get to them in chronological order at the end. Right now, I would like to turn to Professor Mishra, who will say a couple of words about the talk.
Welcome, Professor Merlin Donald, and we're very happy to have you here in spite of these crazy times that we are witnessing, and we're very privileged to really host you on this program. Just very briefly, this program aims at fostering interdisciplinary communication, mostly whatever matters to mind-brain sciences, and we have hosted many important scholars in the past, and we are very happy that you agreed kindly to give your time to us today. Yeah. And we actually have hosted pretty recently Professor Wen and College, who also have contributed significantly to the question of evolution of cognition. But I assume that your take has been a bit different, and we will be very happy to know the points of view. And I would like to say that the audience who have joined with us come from various disciplines, and cognitive science in India is a growing discipline, and particularly the question of its evolution is terribly important. Personally, I think, and as many would like to know more, and I think your talk would be pretty significant in that direction. So I again thank you for getting up earlier and coming over to give a talk. And I also would like to share that Professor Donald is the author of two very influential books. One is on the evolution of the mind question, where he has his important theory, which has a very wide significance in the field. And the other one is on the consciousness issue, A Mind So Rare. So I would like the audience to get the books if they can. And so without further delay, I would request Professor Donald to go ahead and give his talk. Thank you very much.
Thank you so much for inviting me to do this. I've never spoken in India before, and I'm very excited about it. I think India is one of the great centers of civilization in world history, and I'm delighted to have this opportunity. I've been thinking about human origins and human nature for a very long time. That's always been my interest. So I started off in philosophy, and I felt I had to learn something about the nervous system and something about psychology to understand what we are. There's nothing like throwing a temporal light on a problem to bring out patterns that are otherwise invisible. And you can see this in the development of a child, and you can also see this in the way we have evolved. And we have a very consistent archaeological record that has been quite stable, even though the particularities of the archaeological record vary. In fact, the story has been pretty stable, and that we are descendants of Miocene apes, and that in fact we still are anthropoid apes, very much so. And it's quite transparent that we are anthropoid apes, just looking in the mirror, or just looking at our skeletons, that we're transformations of a standard pattern that applies to all the anthropoid apes. So there has been a tendency for biologists perhaps to overplay that and to play down human uniqueness. And there is a long history in psychology, especially the intelligence testing literature, but many other literatures that overemphasize the differences. And I guess I come up the middle here. Now, one of my main concerns right now is where we're going. That is to say, we're in revolutionary times, obviously, technologically. The whole tech revolution is aimed at the mind. That's what it's aimed at, nothing else, and at manipulating the mind. And so cognitive scientists, above all, should be concerned about what's happening. And the only way to really see what's happening is to go into the past and see what happened in the past. Where are we in this adventure, this human adventure that seems to extend over thousands of generations now? So I'm going to try to throw some perspective on this. When I started working on it, I decided that I would throw away all of the methodological constraints that I was carefully taught and consider all the evidence, no matter what discipline it came from. And the principle is this: if something in another discipline, let's say archaeology or physiology, contradicts your theory, throw it out, start over again. You're trapped in a methodological narrow channel, and you have to get out of that. So the story I'm going to tell you is basically set out in chronological terms, but it focuses on three things. Humans are skilled in a way that no other creature is skilled. Humans create narratives. I define language on the level of the narrative, not the word. And that is completely unique. And in addition, humans have a thing called material culture, which includes, of course, writing and a term that I've invented called exograms to describe memories outside the brain as opposed to engrams, which are memories inside the brain. So these three structural ideas will essentially determine the shape of the talk today. Now I just have to figure out how to advance my slide here. What's going on? I guess I just do that. Am I? No? Okay. All right. So smart information technology is already changing the human condition. I love this cover on the New Yorker, which is a sort of dystopic prediction of a future in which humans are very much in the secondary role, and robots and intelligence, artificial intelligence are taking over. Of course, I don't believe, though, it's going to happen, but many people do. And so we should, as cognitive scientists, be interested in trying to determine how we can salvage the place of the human mind in all of this. Now, we're skilled and we are capable of inventing new skills, and that's quite revolutionary. And early on in human prehistory, we now think about 3.5 million years ago in a species called Afarensis, we, for the first time, have evidence of cutting tools being used to butcher animals. These are marks on bones that establish pretty conclusively using a tunneling electron microscope that, in fact, these cuts were made by a stone cutter. The oldest actual tool discovered was about 2.5 million years ago in Ethiopia. The references are given on the slide here. And the oldest sophisticated tool, that is the one that takes a great deal of preparation and planning, is at 1.76 million years old. And so the scenario I laid out in my book wasn't that far off. I wrote the book almost 30 years ago. In fact, the dates have gone back, which is reassuring because it can salvage a gradualistic type of theory, which is what I proposed. So this formed the basis of the first master toolkit. That is, stone tools are the sharpest, hardest material, usually flint and obsidian, and they can make other tools. So you make things out of hide and out of wood and various other things using these tools. The large stone tool, the Julian hand axe, is a crushing tool as well as a cutting tool. And in preparing to build, you've seen a talk by Nick Toth, so you know what I'm talking about here. Now, this early, there seems to be no evidence for language, so we have to explain this in a different way. My argument is that human ancestors were skilled long before they were articulate. And of course, to try to articulate or to explain what the implications of tools this early might be. Well, from a neuropsychological point of view, evolution at this point had to overcome a tremendous bottleneck because no other animal does this. You know, one of the first things I observed, which is still a strong point, I think, is that my dog, and if you have pets, you know this, that almost any mammal can do this. My dog is very clever socially, but when he's hungry, he just comes over and he sits in front of me and stares at me at a certain time of day, and he knows he's going to get fed. It never occurs to him to do this, right? That's a very simple thing. A human would do that right away. Why? He's motorically capable of doing this. He understands the social situation. What is missing? The bottleneck is that the posterior part of the brain, the area of the brain that includes most of the sensory modalities, has to model somehow a situation in terms of action. And action is a different part of the brain. In humans, it's the frontal, prefrontal, premotor cortex, all the way down through the basal ganglia and so on. In most mammals, a very similar type of projection works. So how does that part of the brain model what is it perceives in both vision, audition, all of the different olfaction and so on, and how that's all integrated? That's, of course, not understood psychologically. It's not any better understood now than it was when I started studying, 50 or 60 years ago. This is something we still don't really fully understand. We have a few vague ideas about cell assemblies and so on, but we don't really. So evolutionarily, no, somehow humans overcame that bottleneck and became able to model action around perception. What does that mean? Well, skilled performance involves the accurate rehearsal and deliberate review of what become procedural memories, that is to say, skills that we have learned through practice. So what you're doing in this is you're rehearsing actions to approach an imagined ideal. That's a very remarkable thing. No other creature seems to do that, and I've argued that that is the foundation of our entire human nature and our culture. So I've put the term mimesis on it because mimesis, it's an old Aristotelian term. It refers to, in a sense, the imitation of reality, but it's an imagined reality. So a skilled actor can translate a percept of an event into a modifiable procedural memory. The action model must be modified in terms of event percepts. That is to say, if you throw a spear and it doesn't hit the target, you have to throw it again and modify your action until eventually you know how to do this. Performers learn this uh, by recalling consciously retrievable sequences of action in context. The context is crucial. You throw a spear differently if you're throwing it at a target than if you're throwing it, let's say, at an animal that's moving, and so on. So the giveaway in terms of where this is located in the nervous system is, in fact, human dance, which is quite unique. And this little illustration, which appears in my first book, actually, is still, I think, a powerful way to look at it. In dancing, you hear rhythm and you act. So in terms of the nervous system, we can say you can perceive that rhythm in light, sound, vibration, touch, body sense. Anyone who's been at a rock concert knows what I'm talking about. And in terms of action, you can produce different action systems, eyes, head, arms, and you can map perhaps different parts of the rhythm onto different parts of your body. It's an incredible thing, so you can, if you want, you can blink to the light and move your legs to the sound and snap your fingers and so on, do them all separately. And you can do it any way you want. You can suddenly start snapping your fingers to the light and moving your legs to something else. And so that switch in the center, that hypothetical switch, means that whatever part of the brain does this, it is at the very top of the action hierarchy. It's a generalized capability that applies to all voluntary movement. So that just in the mere fact that so far back in time, Australopithecus was moving in this direction suggests just how time deep this adaptation is. And it is the key that opened up a whole series of possibilities later on. This kind of self-triggered recall, you're performing on your own and you're so triggering your own memories. I call that auto-cueing, the auto-cueing of memory. That entails a link between imagination and action. That is the essence of mimetic imagination. And that is the essence of something I call mimetic culture. Culture is really collective memory banks. That is in human, not in most animals. It doesn't seem to be any memory bank that crosses generational barriers. But in humans, we do that. And so I've proposed many years ago that there was a culture, an early human culture that was based on skill, hunting, gathering, building shelter, but it also moves into expression. It probably involves the proto words of some kind, so because you can coordinate a hunt, you don't need to be able to generate a speech or generate narrative. You can do it with very simple vocal gestures. But the inherently creative nature of this means that you can accumulate patterns of action over time. Tribes of humans could learn one type of tool or one type of skill and pass it on to the next generation. So cultures could differentiate, they could go in different directions. Now, this is a wonderful illustration. Was in a museum in Mosgaard, Denmark. Well, I had an appointment there for a number of years at the university at Aarhus. The early hominin tools essentially consist of transforming materials into something else, right? So changing the environment. And this we know from a number of research over the last 20 years that required pedagogy and extensive socialization. So I propose that humans at this stage were essentially actors. They mime, they pantomime, they gesture. They, of course, become skilled because skill is a replaying of earlier action patterns and the improvement of it. And of course, since we were primates, all of this is layered on top of what primates passed on to us, which is most of what we are actually. So highly emotional, competitive type of culture. So one conclusion we can draw from this is that refined skill was already a fundamental component of human cognition and culture 3.5 million years ago, and it was a culture centered around skilled performance. Now, I want to go on to the second, what I call the second transition. Once you had consolidated for what seems to be about 2 million years, the human as a skilled anthropoid ape, you made a second leap. And the second leap is very much a direct extension of the first one. It is the leap to language. And as I said earlier, I define language in terms of narrative ability, being able to tell a story. I'm increasingly convinced that this started with the first species, Homo, which appeared around 1.8 million years ago, and that some kind of proto-language was under development at that point. The reason is that we have some recent evidence that humans were using fire and cooking and doing very complicated things at least 1 million years ago, and more likely 1.5 million years ago. So Homo erectus was the transition species that led to our sapiens type of species, and was evolving language. During that time, there was an enormous increase in brain size and cranial size in humans, really a further doubling of the cranium. And that has to be due to something. I don't fool myself that brain size predicts intelligence. It doesn't in any simple sense, but within the same species, you have to have an explanation if a species decides to double its brain size. Speech is essentially a hierarchy of automatic skills, the automatized skills, practiced until they become highly automatic. And it involved, I've argued in my book on consciousness, a further evolution of executive prefrontal brain systems that supported essentially complex event description. You don't have to develop narrative ability unless everybody understands that there are such things as complex events. So if you want to describe, let's say, a relationship between a man, a woman, and another woman, and children had by both women, and so on, you want to describe that story, it gets complicated. It's a multi-agent event extended over long periods of time, sometimes years. And the ability to describe that is a very remarkable thing in the context of what primates can do, generally speaking. The other thing about what's interesting about language is that it can be directed inside or outside. So this fellow is saying, is describing something outside of his head, or he can turn around and search his own memory and talk about his childhood. That's a very remarkable thing in its own right. Languages are imported from culture, and we know that they reorganize the brain by providing a highly efficient memory mechanism. Most literate people have 30,000 words or more, and these words consist of very complex neural systems. In fact, every word in the brain, and we know this from both MRI studies and neuropsychological studies on clinical cases, that each word system involves a separate network of that entails syntax, phonology, morphology, meaning. All of these things have some independence from one another. So we're talking about an incredibly complex system. I'm going to put in a little demonstration here just to give you some idea of how much language increases the load on the executive brain. If you have a number of different speakers, you have to track each speaker separately. In a way, you open a memory window for each speaker, and you never lose track. It's quite amazing. You can talk to somebody for 2 hours, and if they suddenly change something, you can jump on them right away and say, yeah, that's not what you said an hour ago. It's a remarkable thing. So I'm going to simulate a little conversation here between Charles Darwin and Wilberforce, and of course it's moderated by none other than Charlie Chaplin. And I'm going to put across the bottom of this a temporal track of what's in whose working memory. So Darwin says the origin of the human species must be investigated objectively. And of course, that enters into Charlie's working memory. Wilberforce replies, but scripture tells another story about our genesis. He hears that, and that goes into another window in his working memory. He's very capable of keeping these separate. So Darwin says, those are beautiful superstitions. They have no objective reality, standard scientific reply. And the other says, your vision lacks beauty. It is cruel and demeaning. So now what you see is that just as in Star Wars, the script is moving back, and the thing that was said most recently is very vivid, and the other is fading, and you keep them separately. This is quite a load on working memory, and this is only a conversation between two individuals. But there is beauty and truth, however harsh it may seem. You cannot explain the appearance of new species or ultimate origins. We're working on it, and so on. You do not inspire people, nor you grant them peace, and so on. And this is, nor do you anymore. So it's getting personal. But let me interject. So suddenly Charlie comes, and so now he's got a third window open in his working memory. Maybe what we have here is a question of non-overlapping magisteria. And they say, what? And so all of this is registered. And then across the bottom, you can see the building load, and this is just in a simple conversation in one individual's working memory. Well, what you have here at the end of it, if you're a normal human being and you've had this conversation, is essentially a model of the exchange, defined in terms of the speakers and your own understanding of it and your own responses. And of course, we do this normally every day. This is the most normal thing in the world. So one of the conclusions of examining a great deal of evidence here was that interactive language networks are very demanding in cognitive terms, and evolutionary selection pressure had to favor improvements in executive functions. And this demand went beyond expanding procedural memory to a vast expansion of semantic memory. And that can explain perhaps what we know to be the case, which is that there was a disproportionate expansion in humans of the tertiary regions in the brain, especially in the frontal lobes, during the last million years or so. Now, we did a little MRI study a few years ago in Denmark with the group I was affiliated with, and which we tried to track the parts of the brain that were activated as people listened to a story. They were listening to a kind of a detective story, and as this plot unfolded, we tracked which parts of the brain were linearly related to the building up of the story over time. And in fact, oddly enough, not oddly in my perspective, the areas that lit up were not the linguistic left hemisphere regions that you might expect, but rather the right hemisphere and the areas that were typically activated in imagination. So that reinforces the notion that although language is very powerful and very unique, it's still floating on the surface of a mimetic imagination, which is, of course, floating on the surface of anthropoid primates. The cognitive impact of having narrative thought, the ability to tell stories and so on, was enormous. And I think you can see that it opens up possibilities such as conceiving identities, autobiographical memory, differentiation of semantic space, the description of large-scale social scenarios. And the result of that is universal, mythic, mimetic culture. That is to say, what we think of as traditional culture. All traditional cultures have shared mythologies, beliefs based on universally accepted stories, and it's normal for individuals to construct autobiographical memories, which is a self-narrative constructed and reviewed with other people who are close to you. Thinking in this context is essentially allegory, and is a very powerful and natural way for human beings to live in groups. Mythic culture creates communities of mind. And the function of all this activity, this collective meaning making, is laid out here in this slide. We confront the unexplained. We validate social hierarchy. For example, kings are usually justified in terms of scriptures and belief systems and so on. The absolute hierarchy of social structure is justified that way. Pedagogy, we develop systems for sharing that knowledge, and all of this governs the flow of values across generations. It's crucial, and it's essential. It's a mechanism. It is the true mechanism of cognition. And as you can see, the brain systems do not have to map onto this mechanism, but they have to. They are a very serious constraint on where it can go. And as learned custom continue to develop through various societies, one of the things that happens is that material culture, things like shelter, costume, tools, and so on, become infinitely more complicated over time. And you end up with specialized skills, highly specialized skills that we develop in modern culture. And that includes high art, and of course it includes things like neurosurgery and astronauts and so on, who learn very exotic skills. The end result of this is a culture that is based on group performance, where both performers and audience need training and education. And all of this converges in special events. This is the coronation of Queen Elizabeth many, many years ago. Every element of British society is represented on a mimetic level. These are all mimetic, the costumes and so on. And yet there's a narrative in the background. And that is the representational culture that governs our society. That's what I call cognitive governance. One of the things that mythic abstraction does is it liberates you from concrete immediacy. It allows people to imagine futures, to dig themselves out. But now, all of this is just a setting for the next step, which is we're still in the middle of this, the third cognitive leap, which are artificial memory devices. Artificial memory devices are what I call exograms. They're memory records outside the brain. And the existence of these memory records has enabled modern cognitive systems to escape the limitations of the brain to some degree by means of external and non-biological memory media. So evolutionarily novel properties developed when exograms appeared, because I spent some time describing the structural change in the relationship between the working memory and the rest of the brain that is the result of this, but it's considerable. These records are quasi-permanent. They can outlive individuals. They have unlimited capacity. They essentially are, now that we've gone electronic, our external memory records are infinite. There are new retrieval options. You cannot Google your brain, but you can Google the memory, the collective holdings of all the libraries of the world. They're reformatable in drastic ways, and they're also programmable. That is, increasingly, these devices can perform real cognitive work So cognition has been some degree exported outside the brain, which is a very remarkable, in fact, revolutionary development. I've called this whole system the external symbolic storage system, which became more structured with the invention of writing, but it has roots way back in the Upper Paleolithic period, the multi-million year period when we developed into our current modern selves. Writing had beginnings in Egypt and Mesopotamia, and was supplemented by oral culture at first, but it has a cumulative nonlinear history eventually that has founded the foundations of analytic reasoning. One of the positions I took in my book early on was that analytic reasoning is not an innate capacity of humans. It is, in fact, a rather arbitrary thing. Now, it's a set of cultural customs, basically, that we discovered work wonders in fields like science. Exograms can take many forms. They can take, in fact, as I'll say later on, they can combine and recombine different parts of the brain and the intellect in very productive ways. One of the things that this produced is what I call theoretic culture and hybrid mind. In many cases, in fact, all modern people, all you and I are hybrids. Our minds couldn't possibly operate the way they can without the exographic world that we live in. And it has enabled the invention of institutionalized paradigmatic thought. As graduate students, you are entering into the great maw of the institutionalized paradigmatic thought training system. That's what you're doing. These hybrid cognitive ecosystems now are universal in human culture. They are tremendously powerful. They become almost too big for us to manage. And it is a joining of the inanimate universe as we have engineered it to our brains. In other words, that's why it's hybrid, because it's partly biological, the system. We are component parts, and partly non-biological. It has now encircled the globe, and this has happened ridiculously fast, much too fast for any kind of evolutionary adaptation. We are now entering new territory, as you can see, and that's the advantage of a global view like this. You can see just how shocking and sudden this change is. It took millions of years to get from mimetic to oral mythic culture, and it took thousands of years to refine that to a certain point where these symbolic systems were invented. And then technology essentially has almost taken over. One thing that concerns me now is the emerging dominance of the machine. Global knowledge environments are increasingly machine-driven. We have 24/7 stock market trading electronically at blinding speeds. No humans in the loop anymore. That should be, in my view, illegal, but that's what's happening. We have radical impacts of this technology on our time perception and our perception of our own cultures. I could go on forever on that one. A kind of hermeneutic revolution. We have, the cinema, for example, we have a reduced presence of shared coherent narratives because our cultures are becoming so multicultural. And a fusion of human machine systems, which I think the smartphone is a very good example. People walking around like zombies with their smartphones and responding to a constant barrage of input. The economic pressure has pushed people into this behavior, and I think a cognitive scientist, above all, should be examining this and say, what on earth is going on here? The third transition is not equally present in all anatomically modern human cultures. And that's fairly obvious. It occurred in a few places, and it's now spreading over the globe. The question is it going to destabilize us as a society? You have the same old brain, basically, but it's been jiggered around and reorganized and rewired in many different ways. And there's a great threat, I think, to personal autonomy and in the traditional definition of the term. Whether that's good or bad is something that we have to decide. But if you take my overall model and you think of it in terms of episodes being the core of primate society, I'd call it episodic culture. And then you have the physical aspect of skill, developing skills, hundreds of skills in the mimetic culture centered around that, the rituals and customs and structures that come with skill. And then you have mythic culture centered around linguistic representations, which retains all the previous adaptations, right? And then finally, the external representations that come through writing and technology and built environment. Built environment itself is a memory system that tells you a lot about how to behave and what's possible and so on. Intrusive tech, modern tech, invades all of this and can scramble them in ways that were not possible before. In a sense, it's tremendously dangerous. And I think the Trump phenomenon in the States is an interesting example of how even in a culture as literate as the United States or Europe or India, technology can go back to earlier levels. And so that the media are being used essentially to create mob rule in the United States. There is a serious possibility that they will regress to, unfortunately, a traditional form of government, which is dictatorship with support of mobs. Let's hope not. They're in the middle of a very existential struggle here. Now, just to summarize all of this, there's a table. This is a slight modification of a table that's been widely circulated in the literature, especially through anthropology, developmental psychology, and so on. Early on, primates lived in an episodic culture, and they were limited by relatively isolated brain-based systems. The metaculture came along for a period of several million years based on gesture, skill, tool making, and brain-based gestural communication. So we're still talking about brain-based cognitive skills. Metaculture starts to further elaborate on that structure. Crafted external symbols appear early on, long before writing. You have shared oral culture and the development of religion and various types of institutions, and governments actually started appearing along with abstract symbolic systems. But once you get writing, you have formal education systems. That's for before we had writing, we didn't need education systems. And your large-scale theoretic artifacts like encyclopedia and archives and systems of laws imposed cognitive governments from the top, massive external memory storage. Most early writing was for taxation and for government. And you have institutionalized paradigmatic thought at this point. The question is now, are we entering a post-theoretic stage? And is that possibly a danger to human survival? We have robots, artificial intelligence, smart artifacts, engineered experiences, which have not really been assessed by psychology. We don't know what exposing a child to 10,000 highly emotional videos does. Okay, but that is a question we have to answer on a global scale. We have to scale up psychology and stop silly studies on 16 people who are college undergraduates or something, and get serious. One thing that's happening now is mode relativism. That is, you can think different ways at different levels. We are able to move around in this cognitive space in revolutionary ways, and the hybridization of cognitive operations, when you start exporting things to computers and then reimposing patterns on the brain and so on, you create a smart cognitive ecology, and that is potentially a revolutionary development. So conclusion number 5 is the brains of individuals are no longer the main source of human cognitive power. We're talking about distributed networks. So a large corporation might have 100,000 people linked electronically, thinking. That's what they do, and inventing things and manipulating people. A machine agenda is emerging, whereby the human or animate component of our human machine system is shrinking in influence, while the influence of the machine component is growing exponentially. And I've argued that this is possibly the start of a fourth transition. I wrote a paper that was just published last year on this topic, which I can make available. It's not easily available. It's in a book published in Denmark. We're in unknown territory here in terms of cognition, and some of our. I wish that psychologists would lose their obsession with essentially small-scale, almost trivial issues, and focus on these huge issues, because somebody's got to do it, as we're slipping into this new world. I've got to torture you a little bit with food for paranoia here. Imagine that you have a globally connected billionaire overclass. Of course, we know no such thing exists, but it's just possible it might happen. Potentially in possession of surveillance technology and control of a modern military apparatus, reinforced with robots and AI and advanced genomic capabilities, possibly altering the genome even. Possible scenario, traditional humans become truly self-domesticated like cattle, and the rule of a sociopathic overclass becomes entrenched and possibly irreversible. Ultimately, the overclass meets its match in machines, and eventually they become unnecessary. And there's a lot of talk in military world. What happens if there's a rapid nuclear strike and you're only getting 5 minutes notice? You don't have time for a dithering human being to be in the loop. So this is a very dangerous situation. We have created these smart creatures, these robots, and the question is, at what point do our mind tools start to work against human progress? Is human cognitive evolution moving forward or backward? And that forces us to reflect on what is a human being, what is the ideal human life, and what is the purpose of cognitive science at this point in history. It's all very well and good to understand, the micro aspects of our biological capabilities, but in fact, that can work against us, I'm afraid. During my lifetime, my professional lifetime, it was about 50 years since I was a graduate student, that research has been used against us very effectively. It's psychologists, in a sense, who have changed the world more than even physics, because modern management science, as they call it, is mostly applied psychology. In fact, a good deal of it is applied behaviorism, and human beings are being corralled into extremely controlling management systems, much the way rats and pigeons were by B.F. Skinner, 60, 70 years ago. And don't kid yourself that this is entirely for our benefit. It isn't. So we have to be careful how psychology is applied. They have now applied the psychology of attention to addicting people to video games and to casino games and the rest of it. So you've got to be careful how this research is being used. And I would say I'm more concerned about that than I am about the micro aspects of my perception or my episodic memory or what have you. Anyway, that's where I'm at in my thinking. I'm still trucking away, and I think I hope some of you will do the same and try to think about these things. What is the optimal cognitive arrangement for society and for human beings, and how can we optimize our capabilities? And I'll leave it there. Thank you.
Thank you, sir. That was, I think it's given all of us a lot of food for thought. I'd like to ask Professor Mishra to have a discussion with you on some of the main points that you put forth. Professor, you're.
Yeah. Thank you, Professor Donald, for a rather wide-ranging talk. And very rarely one comes across straight talking in cognitive science, because we are all addicted to doing little paradigmatic research, and we feel very happy. And I myself am beginning to be a critic slowly, although I am pretty young now to be a very vocal critic. But I have to ask a couple of things. You spoke about language and its evolution. As you may know, that there are many views on language evolution with regard to both brain or as a symbolic apparatus that might have come as a byproduct. And many distinguished people from various fields like Chomsky and other collaborators and Bickerton have taken different approaches. But I go with your understanding that language primarily forms some kind of an interface between the mind and culture. So language special status, as it has been being sold as a symbolic system, a model, and so on and so forth, which is the large consensus view in this field, even the computational theory of mind view, basically, which further popularizers have taken it up. So, how strong are you on it now, the embodied character of language than this symbolic computational?
Well, I think I made an early decision. When I was a graduate student, Noam Chomsky came and talked at McGill, and I listened to him, and he was already becoming famous, even though he was just 30 at the time, I think. And the truth is, I found his ideas incredible. That is a non-starter from the beginning on an axiomatic level, because he was proposing an evolutionary miracle. A number of people pointed this out to him, and he said, well, that's your problem, but that's Chomsky. Chomsky was a supremely confident guy, and he believed in his system. And in a way, at the time, there was a worship of mathematics and quasi-mathematical solutions. But in fact, I think that it was a complete dead end. That is, even within that field, universal grammar had been pretty well abandoned. It just doesn't exist. What language is that? You cannot have a context-free grammar. You have to. Language is about meaning, period, and it's the linguistic environment that creates the complexity of language, and the linguistic environment includes the complexity of cognition itself in human beings, which is so exquisite and so incredibly complex. So, especially considering that we are social creatures and communication systems greatly complicate our lives, as I pointed out in my little demonstration earlier on. Mentally, a lot of our growth was driven evolutionarily by having to adapt to a multi-agent communication environment. Okay, so we have this mimetic imagination, and when I saw Joshua Green's address, I looked at it, and in fact, he's making very much that point in a very strong way, but it converges with certainly a lot of other evidence, and I think we have to perhaps abandon the even though I was given some kind of an award by a semiotic association last year. The truth is, I'm a cognitive semiotician. That is, I don't believe in somehow magic semiotic world that goes off on its own. Once you get into mathematics and external and exograms, that's different, because you do have a self-propagating system, but that's not what exists in our brains. We are the ones who invented that system. It is a byproduct of our technological and social development, but it's certainly no model that can be retrojected onto the human brain. And I discussed that at great length in both of my books. That's a key question, a very good question, at the very center of it all. But of course, I've had a lot of pushback on that, and it's not everybody's willing to go along with it. But Ray Jackendoff, who's a pretty well-known linguist, who tried to break out of Chomsky's the Chomskyan trap, if you want, himself said to me, 20 years ago, he said, "What you're suggesting is an awful lot of research. It went down a dead end." And I said, "Well, I don't want to say that, but the truth is, that's probably true." And that happens. That's okay. I mean, that's part of science. That's part of scholarship. It's fair enough, and not everything works out. Yeah, there was a very good reason for phlogiston theory, but it didn't work out. It happens, But so of course, some linguists may not be so friendly to that position. That's the way it is.
The other important point, I was reading some of your work, and is this idea of distributed cognition, that it all began when a lot of brains or minds came together and some kind of interactive scenario emerged, and that has remained so. And probably that is why these large companies that are using our minds today for a different end altogether, which you pointed out. So it looks like that's one of your main theoretical stands over a period of time. That is not with regard to just how one brain or one mind start cognizing, but it is a collective social process, and that kind of remains so, as opposed to some other theoreticians who have looked more at individual capability in artifact tool making, and trying to look at the brain areas that are responsive to such process and theorize. Although I know that you have studied cognitive neuroscience and you did have a background in biology and cognitive neuroscience, apart from philosophy. So, because a lot of people now are interested in this distributiveness of cognition, which kind of spans all over all the people that are currently there in the earth. It kind of includes everyone. So, any more thoughts on that? The future of that idea?
Oh boy, well, that's a huge question. I think yes, I mean, at the core of my message is the fact that we are living in distributed systems. That is, we are, in a sense, we're an ambassador for our culture and our upbringing. Okay, we are locked in time and space. We can't be born in a different time and with different language and different brain organization. We're very much a product of the time, and even the greatest thinkers in history were very much a product of their time. And in a sense, the social system, the whole system, is a search engine. Is looking for the right nervous system at a given time. The skills that are involved in, let's say, high-speed motorcycle racing are so complex that the only way you can explain it is that society invented all these devices and these spectacles, and we're just looking for the right nervous system. There's a great reward if you just happen to have the exact right combination of insanity, daredevils, bravery, and coordination. But it's an accident, and it's the same thing intellectually. I mean, we had no use for mathematicians or people who had those abilities. Let's say 5,000 years ago, there was nothing for them to do, right, with that particular constellation, and so on. So different generations need different types of nervous systems, and what we have right now with this enormous population of 7.5 billion people was an incredible range of types of people, and what it's going to do with that range of people, we can't know really, and it's too complicated to predict. It's a chaotic system. On the other hand, we can, in our own way, try to control what's happening. And I think religions were a very good example of an adaptation that was primarily cognitive, but was on the social level, and that coordinated a lot of things and did a lot of good. We don't have a modern equivalent, and it's, I think, rather important probably that we find a modern equivalent to provide the structures and harmonies and so on needed. You need to align cognitive systems to get them to work together, and that's what training is all about. That's what education is all about. But increasingly, it's, at least in the West, we've been eating our own children. With the invention of deconstructionism. I used to have a sign on my door which was, "Who put the con in deconstructionism?" It's just plain destructionism, but even though there's an element of truth, it can be very destructive. But we need structure, and it is really our greatest dilemma in the modern world, because we can show that structurally we are very brittle and very vulnerable as a distributed system, and I can't predict where that's going to go, but it's a great adventure to try to think about it and try to sort it out. And I think we need to stand back, and especially people who are highly trained and highly educated, take a look at this situation and realize that our skills are directly relevant to the future of the human race, of the survival. I don't know whether I answered your question at all, actually, but I did try.
I always wondered, with regard to the question of the timeline of cognitive evolution, I would like to know from you, is the cognitive evolution, is it still in its infancy, considering that the major cognitive systems kind of evolved 40, 50,000 years ago, maybe 60,000 years ago, a rough estimation, and it's pretty recent. If we check the recent discoveries that the Homo sapiens have been around since at least 3 million years. So it took a long time, and the cognitive systems like attention, working memory, etc., are pretty recent. Because that is important in understanding how well are we adapting to these new challenges that you spoke about. What's your take on this? Has it come along so that it can withstand these challenges, or it's very in its infancy and it needs its own time to mature? I'm talking about the cognitive systems, because that essentially is cognitive psychology's holy grail.
That's a very, very, very good question, and the question is, I think we've had no time at all to adapt. That is, just in terms of evolution, civilization is about 10,000 years old. Okay, prior to that, we were hunter-gatherers living in nature, more or less, and highly organized, very intelligent, but we didn't have the density of development that occurs. And it's only a few hundred years since industrial civilization, and it's only a few decades since the smart tech civilization came. So we've had no time. Your brain and my brain are the same as our grandfather's brains, basically, except that it's been jiggered around, connected differently, and so on. The momentum has gone out to the exographic hybrid world, I'm afraid, and we are trying to hold on. I'm really concerned about that. I think such wonderful things came from earlier human culture, and that if you look at a modern city, very often it's hard to find that sense of beauty and gentleness and that brought out the best in human nature. And we have to find our way back to that, in my view. If we go too far in the machine direction, it could cause us to go collectively, literally insane and destroy ourselves. We have to go and find a way of recapturing some of those things. And I think modern architects are trying to think that way. Modern city planners are trying very hard. Jane Jacobs, who was important in the reaction against the automobile, for example, in New York City and Toronto, had, at the end of her life, was very pessimistic about where cities are going. But cities are a good reflection of our dilemma, because that's where it's all concentrated. It all comes together. And what do we want, and who are we? That's a tough question. And but it's being brought to a peak by the fact that the two largest powers in the world right now, militarily, are both tending towards a kind of traditional authoritarianism, which is, to me, a defeat that could be very dangerous. But what cognitive science can do is simply to throw light on these developments and hold, people outside the field are very interested in this. Everyone, I've interacted with economists and business schools and military people. I've given talks at NASA and all kinds of places. They're very interested in this. And yet cognitive science keeps on chucking away, just like I'm an easily bored person, and I kept moving as fast as I could towards the big picture, because I think I realized that, and I realize more now that I've been retired for a while and I've connected very widely outside my fields of specialization, that it's a big world, and cognitive science has a lot to offer, provided we understand that it is a big world. It's not.
I would like to, when cognitive science began as an enterprise, it had a very, very high spiritual ambition. But do you think that it is actually, in the last 40, 50 years, it's taught in behaviorism of a kind that it doesn't want to acknowledge, whether it is computationalism or neurotracking, but it's behaviorism at the end of the day. And in that, it's caught and it can't come out. And that it has taken as the high achievement of being scientifically or right on the main tracks in 16th century. So because that was its ambition. So it simply cannot acknowledge the kind of questions like studying the real phenomena out there, how all the minds are coming together, why conflict is happening between nations, and how to stop all of that. Because these are the real questions. So cognitive science has gone wrong somewhere. This appears to be or it cannot recover. It simply it's beyond it now.
Well, I lived through the cognitive revolution, and I was, but I was classically trained, so I had a lot of humanistic training before in a way, when I went into psychology, I was learning the language of the enemy from the point of view of humanism. Psychology is somewhat dehumanizing, and so you put somebody in a lab and you put earphones on them and you force them to look at a screen, and what can you possibly say about a human being? Well, you can sort of focus on something, but it's a pretty narrow view of who they are as persons. So it's important, I thought it was kind of amusing that so many people were using computer models to model the mind, and I used to collect these things, these little diagrams that showed, where working memory was and how it was all organized and so on. And I had a whole filing drawer full of these things in the pre-digital era when I was a student, and because it was fascinating. But there's something kind of funny and ironic about this soggy, wet creature that we are. We are animals, when we ooze and we perspire and we slither and all the rest of it. We have to sleep and we have to eat, and we're very messy. And thinking that we can model ourselves on computers, things that we built. I built the damn things. When I was a student, the university could not afford to give a student a computer. The only people that had computers were banks and the Pentagon, And so I had to build them out of digital units to run my experiments. And if you do that, you realize how incredibly dumb they are. I mean, it's just, they are. The architecture of a silicon chip is incredibly simple. If you compare it with just a bacterium, you can't even, there's no way to really describe the complexity of one cell, and yet the computer architecture is really very simple. A von Neumann architecture is a very simple idea. I mean, it's just silly. We do tend to think metaphorically. So current analogy at that time was the computer. So everybody borrowed a computer and they started applying it in psychology. This is the same as the Freudians applied sort of steam technology. You build up pressure and it's got to come out somewhere. So it's kind of a silly idea too. But we're struggling. We're trying to understand ourselves. I think in the last 30 years, 40 years, especially in developmental psychology, which I think is a superb field, the theories have become much more real. They are acknowledging the complexity of a developing human being, and also more socially connected. So it's happening even in neuroscience. People are starting to understand that you've got to take context into account. You have to start looking at what we really do with our minds. And so in a way, the neurology that I learned when I was young is curiously archaic. It's almost like doing archaeology to go back and look at papers of 50 years ago. It's kind of interesting. But I think we are getting somewhere, but we've got a long way to go. And what concerns me is that the machine changes that are occurring so fast are going to just swamp us, that we won't be able to handle it. But
one last question. You had a pretty long career, 50 years, and you have written 2 wonderful books, and you have given a lot of talks. Any particular idea that still remains attractive to you? One idea, either related to mind, culture, brain.
In terms of experimentation?
Any theoretical idea?
Let me tell you, if I were 25 years old and looking for a thesis, I would be, and I wanted to do something experimental. I think we're missing a key aspect of the nervous system, of the brain, that is completely missing from the equation. I was taught by Donald Hebb, and I subscribed in a way to Hebbian theory early on. A lot of people did, and so that you tend to think in terms of neurons being the thing that matters in the nervous system, whereas I've, after the fact, come to regard neurons as hewers of wood and drawers of water, as the mundane workhorse structures in the nervous system that are responsible for getting information into the nervous system and for moving muscles to cause things like speech to occur and so on. But I think they're much too sluggish and leaky and messy to possibly be the computational core of high-level representation and thought. We need a system that can explain the simultaneous integration of parts of the brain that are as many as 5-6 centimeters apart. Okay, you have simultaneous multimodal experiences that are so high-powered and so precise that they couldn't possibly be communicated through neurons organized essentially in AND gates, NOR gates, and that type of concatenation of a system. It can't possibly be. You need some kind of simultaneous integration. Now, Roger Penrose recognized that many years ago, and some physicists think that something like entanglement in neurotubules or something like that might be a system that could cut right across and through the nervous system and integrate neuronal activity. And so used to think in terms of electrochemical soup. I did a lot of electrical work early in my career, but I don't think we have a handle on it. So what we need is some kind of a I wrote a paper just in 2008. I think it's in the Journal of Physiology in Paris. It's about what I call a slow process. That is, when this conversation has left some kind of an organization in your brain. Okay, it's going on for an hour now, and you remember what I said, I remember what you asked, et cetera, et cetera. And what is that? It can't be the high-speed neurons that I was looking at. They come and they go. They don't endure. But there are processes that endure. What is that process? That's where I would be looking. And that MRI study I showed was the first attempt to look at it. I don't do MRI. I mean, we needed a team of 6 people to do that study, and I was just an idea guy. But I mean, I think we're on the neural side. We need to move into large scale studies of that sort of thing. On the large scale side, we need to look at human adaptability. What's the range of stress and challenge that we can handle, and somehow make recommendations to corporate and governmental sector as to what is tolerable for not only happiness but sanity in human affairs.
All right, so thank you very much for this extended discussion. And now, if there are any questions from the audience, we can take them up. So over to Siddhima.
Yeah, so we do have a couple of questions, but before that, I have a question of my own.
Yes.
You talked about the exographic network, and I just wanted to know if every brain in the globe is becoming a component in a very large system, as you showed in that image, then where does our conventional understanding of individualism and collectivism fit within that said system?
I don't fully understand that question. So can you just rephrase it a bit?
Yeah, sure. So I just mean that, do you think that being on the internet, being on the internet and being in that connected environment,
yes,
the exographic network that you
yes.
described, do you think we will still be able to retain our conventional definition of what is individualism and what we are as individuals?
That's a tough one. I mean, that's one of the great dilemmas of your generation, I would think, because you're bombarded with so much stuff and you're embedded in these high speed. I don't use that social networking. I was on LinkedIn for a while and I bailed out of that. I found it so intrusive. I don't know how you can stand it. I mean, it's incredibly intrusive and controlling, and it's of great concern to me. I just don't know. I mean, I don't know how that should be a concern, and that includes even in clinical psychology, because I think we don't know the long-term effects of embedding young people in these at times viciously controlling social networks, and also the educational implications are probably tremendous. I mean, the last class I gave that was an actual class, we had a long discussion about whether people should be allowed to have things like laptops and smartphones in class at all. My preference would be not, because we were educated to be autonomous thinkers, and that was always been my goal with students, to teach them how to think for themselves. But it's a dilemma. On the one hand, you have all these tools, which the founders of the internet thought were going to liberate people. You can have access to the whole world of knowledge that was not available before, except people with special access, and so that should strengthen you. On the other hand, you're now embedded in these social networks which are so controlling. That's the great dilemma of your generation. You got to solve it. I'm too old. I can't do it, and I'm not in it anyway. I've been spared. I had my own problems, but that was a generation or two ago.
I just have one more question. Do you think we can look to our ancestors and we can look to our history to solve the problems of this generation?
I mean, each generation has to solve its own world. That's the truth. I mean, we can set things up, and we set up theories and so on, but they change, and the experience of the human beings changes, and so we're all flying blind. We just make it up. We don't get to choose when we're born and what the circumstances are. But I just wish that we could slow things down. Quite honestly, we need time. We need time.
Okay, I'll move on to the questions that our attendees have asked. So you mentioned that we develop speaking. So this is by Vaishnavi Mohit. She says, you mentioned that we develop speaking ability to communicate complex narratives, and that's what makes us unique as a species. I think what also makes us unique is the ability to prevent context inappropriate speech. Would you say that
Could you
this is?
repeat that last sentence?
I think what makes us unique is the ability to prevent context inappropriate speech. Would you say that this ability came to us along with the ability to produce coherent speech, or would you say that it requires additional skills such as inhibitory control, monitoring, context, etc.?
Well, I think that's an interesting question, especially from a linguistic point of view. I think it's a very strong argument to support the notion that language is a surface epiphenomenon floating on top of an intellect that's essentially imaginative, and the fact that you can distance from yourself completely from what you're saying and utter things that are completely inappropriate or change the subject, or which somebody like Trump does routinely all the time, that means that language is not control. It's not in control. It's the imagination that's control. You can produce language for a number of different purposes, and that's an interesting twist, because a generation ago, linguists were absolutely sure that language controlled everything. It's the other way around. Language is to me, it's an epiphenomenon, but a very important one that reorganizes the brain and reorganizes things down below, as it were. But yes, you can certainly distance yourself from what you're saying, and I hope I understood the question. But I think that's what you're saying: context inappropriate speech. Yeah. Yep.
Okay. Harish Chulka asks, "Sir, what is the future of military psychology and artificial intelligence?"
Well, I think the danger in the military is that we're going to allow humans to be taken out of the decision loop, and it's almost inevitable because of the speed of modern weaponry and so on. I would much prefer that that the military not have artificial intelligence. It's a fact of life, and we just have to deal with it. So I would think that one of the important things is to work on security very highly and control very carefully the purposes to which this sort of thing is put to. It's potentially very dangerous to leave planning and decision making to robots. I mean, even in something like a drone strike, they're talking about autonomous drone strikes where the decision is made by artificial intelligence. Oh boy! But I mean, I don't think that's not something to be addressed by an expert in artificial intelligence. That's something to be addressed by somebody who has a perspective on social and ethical issues. And it would help if they knew something about artificial intelligence, but developing artificial intelligence is not going to solve that problem. You're not going to solve the problem of exporting decision making to artificial intelligence by creating artificial intelligence that that controls the exporting of decision making to artificial intelligence. See, it's an endless loop, and it's not going to solve anything. We're in a we're on a knife's edge in that one.
Okay, there's one last question by Harish Chuluka again. He's asking, is evolution of technology increasing the social inequalities, or is it perpetuating these inequalities? How is technology shaping the growing inequalities of society?
Would you read that last sentence again, just a bit slower?
How is technology shaping the growing inequalities of society?
That's one of the questions that needs investigating. It's a very good question. I mean, it's not so much. There are several possibilities. I mean, one possibility is direct implanted stimulation. For example, deep brain stimulation. In Cleveland, there were a lot of people interested in deep brain stimulation, but for medical purposes, that's okay. But conceivably, that could be grossly misused. The more normal type of effect of exposure to, let's say, smartphones and TV and the internet and so on for so many hours a day for your whole period of development, that obviously needs long-term studies in using all the technology we have. And I was on the European Research Council for 6 years, and I didn't see a single grant. That just recently, I mean, it came off 3 years ago, and we looked at big grants from all over Europe. I didn't see a single one that addressed that question, and it's absolutely critical. We look at children and over longitudinally over 10 years and see what happens. We don't know, and that's a critical question and a very good question. If you're looking for a field that's ripe for development, that's one.
I would like to add one point to this question. Right now, you see that we all have moved on to teaching online, and in India there has been a growing debate, and I'm quite sure in other places as well, where the socioeconomic variables are influencing students' ability to accommodate these radical changes, as well as faculty, because we were not prepared as a country to really adopt so soon. And internet speed and devices and everything, and universities and colleges need to start their semesters. And it is a real problem, whether you look at it from country-specific socioeconomic variables or as a global problem. But I think this is just one problem, and the other problems are obviously related to more economics and finance, and whether massive companies, as Merlin indicated in his talk, are really destabilizing us more than exploiting our minds than giving us anything. So,
well, I mean, you're in a way you're singing my song, because the last two periods I had in university, I was a department head and department chair, and one of the things that did concern me was that they were, in a way, imposing a tremendous burden on the academics by insisting on these coordinating systems like PeopleSoft. I don't know what ones you use, but systems that, in a sense, make professors do their own accounting. They are downloading all kinds of tasks, including editorial tasks and so on, onto the faculty, and of course, faculty are left with no time. I mean, it is a system of control by bureaucracies that are often not transparent at all. And that was just beginning when my last session as a chair, and now I think it's progressed further, and I'm not happy about it. I would think it's a system of control, and it is the same thing is happening to doctors, to physicians, to hospitals, to all kinds of organizations. And it is a tremendously controlling world that we're entering into. And I would say one of our main tasks will be to find ways of resisting it. Um, it's a concern at the core of everything. And I'd refer you back to my New Yorker cover that I showed you, of the robots walking by and the man sitting down with a tin cup begging. We have to do something. And the bureaucracies are the servants of the machine model, in my view. And they do produce some wonderful things. There's no question that we couldn't build some of the buildings we build and some of the engineering marvels without all this. On the other hand, at what cost? As a psychologist, I rather like human beings as human beings rather than as employees of massive systems. Anyway, that's just my bias.
Yeah, the technologies that there are. I mean, today I was just thinking, what would have happened if we did have the coronavirus pandemic, but we didn't have internet? What would have happened if this happened in the 80s or 90s without the internet? Because today we seem to be thinking, okay, life is not that bad after all. I can see and talk. But, so at times you feel like it's a blessing in many ways. But if you look at overall larger civilizational effects.
Oh yeah, we're all totally addicted. I mean, yeah. I think we're totally addicted. Even I am. There are many good things that come out of it. We just have to be careful where it all goes. And I think it's important to consider traditional human values in the middle of all this. That's all I'm saying.
Look at the way, Merlin, people have, some thinking people have adopted to technology. Like David Hockney, the British painter, has now published basically art drawn on his iPad. So, imagine painters of that caliber using iPads to basically do the same painting and just transfer it quickly over and get it printed overnight.
Yes.
And, they're adopting the new demands, or you can say the shorter attention span, because anybody can at least do that, because anybody just cannot learn oil painting of the type. So anybody can at least scribble something on an iPad and get away with the feeling that, okay. So nevertheless, Merlin, I think we have taken a lot of your time, and you have been very kind in giving us the time. And I'm quite sure those who have heard us today in India and anywhere would benefit from these wide-ranging points, and they have their own questions. And I thank all the audience who are watching and who asked some of the questions. And the questions and this discussion can just go for a long time. And I hope that these strange times will come to an end in some way. It's just a matter of waiting, both here in India and Canada. And we are again thankful that you agreed, and we will continue doing this, attracting bright minds and sharing their experiences for mutual benefit. Sometimes we will take up interesting questions, questioning even disciplines and where are they heading to. Like today, it came at least in some points. So I thank everyone. And
Professor Donald, would you be able to take a couple of other questions, because suddenly people have?
Yes, I could. Yes.
Okay. Great.
Okay. All right.
Thank you so much. So So Harish Chilaka asks, how can we save the psychological research from being used for malicious intentions or political benefit of few leaders, certain powerful individuals / network of billionaires?
The only way you can is by organizing politically and resisting it. The old-fashioned way, that's the only way. That's simple, straightforward answer.
Sneha Kedia asks, you mentioned that cognitive science has a lot to offer to the world. Can you elaborate on some of the important fronts it must prioritize? At this point of time, can cognitive science contribute to shaping development of the next generation to move forward in evolution?
Well, I think cognitive scientists could get organized a little more politically. Science has to proceed in its own path. So if you're trained in a specialty, you have to pursue that specialty. There's all kinds of professional contingencies that force you to do that. On the other hand, we haven't, as a group, organized the way, let's say, medics have organized and engineers have organized and so on, to take positions. And a lot of the issues I've raised really do have a big political aspect. And so I guess in that sense, the field should engage. We know a lot. We know a lot about why the world has gotten to where it is. And so that side of it, I think, is purely political. You have to take positions on all kinds of issues. What should universities be doing now, for example? What are the limits of massive online courses and various other types of training systems? What is lost when we're not physically there, which I think is a very considerable amount? Then how do we reorganize our education systems? That's a big part of it. To cope with all this, and quite independently of that, the study, the academic study of the processes, the cognitive processes themselves, should be causing us to study our limitations, And that question earlier about what technology is doing to the young developing brain is, to me, a tremendous priority. I mean, if you could establish that something bad was happening, I mean, maybe it isn't, but if it is, we should know about it. The way we should know that carcinogens generate cancer. It's crucial to society. And if we're actually making people less able to cope or more inclined towards breakdown, or more brittle, or lacking certain entire domains of experience, so we should know about that. But I just haven't come across a single large-scale study, and these have to be large-scale studies. They can't be little tiny studies, because you can't generalize from little tiny studies. That's something I learned a long time ago when I was doing a lot of clinical research, that if you do a study on 20 people of a drug, can you generalize it to 200,000 patients? Well, not easily. So you need large-scale studies. And so I think some of those are being done, but not very many are being done by my cognitive science departments. But if you want to, there's a whole list of books on this issue that have come out in the last 10 years. There's some very, very good writers thinking about this. One of them is Jaron Lanier, who's one of the founders of the internet. Another one is Nicholas Core. There's a whole sort of list of those. If it would be useful to you, I could provide that. Sometimes in the context of this talk, I do provide that list. Would you like that? I can send it to you.
Yes, definitely. Yeah.
Okay.
Thank you. So just one last question. Is there any way of studying small indigenous groups, those that are still not entirely under the grip of technology, and
yes,
they can show us the way forward?
Well, that's anthropology, of course. That's require you to go into anthropology. They've had tremendous problems in that area because of the postmodern approach, which claims that you might endanger them, you may contaminate them just by entering into their space. On the other hand, that we would never find out if nobody had ever entered their space, and human beings have been entering one another's spaces for rather a long time. But that is a very complex issue, and I recommend that whoever asked that question should look into anthropology, because I think our cognitive anthropology is a growing field. There's a handbook. Oxford has just come out with, I think I contributed a chapter. There's a handbook of cognitive anthropology, a handbook of cognitive archaeology. There are a lot of new fields emerging in cognitive science and psychology that are merging adjacent fields. And that's certainly an important one, because one of the things you might find by studying human groups that have not been part of the technological revolution, if you want, would be what we're losing as well as what we're gaining. They have enormous skills that we have lost simply because we haven't had any opportunity to develop them. So there's a win-win situation there on both sides that we can find out more.
Okay, I think, yeah, we'll end the question answer session there. And I just wanted to really thank you for coming online and talking to us today. I think we've gained a lot of insight from what you discussed and what you talked about, especially in the day and age that we are living in. I think it was a crucial talk. Just to end the talk, the next Cogtalk will be held similar to this on the 29th of August, and the speaker will be Professor Bernard Hommel, who will elaborate on the mechanistic underpinnings of psychological phenomena and human behavior. And please do register for this. You can go to the lab's Facebook page or the website and register there. So thank you to all the attendees.
We have done well, although in the beginning there was some technical problems, but I think you went very well. And thank you, Merlin, for all your time, and I wish you all the very best. And hopefully, I was actually scheduled to travel to Canada this summer, but as events turned out, and I might be there again, and hopefully we will meet in person.
That would be lovely.
Yeah. So thank you all, and see you in the next episode.
Thank you very much. Bye now.